Now, for those that were here, welcome back. For those that weren't, we had a really great discussion on novelty. And so we were trying to figure out, are there ways to solve behavioral questions, but without needing to know as much as most coders know, which is extremely complicated. So this week, we're just looking at the exploration of low-code capabilities and how can we use these platforms and how can we use our own low-code platform to build more human-centric engagements or interactions. Now, for today, I'm not going to spend that long on the slides themselves. I really would like it to be more of an open discussion, but we do have a bit of a presentation section at the beginning to demonstrate an app that we've built using our low-code environment and another accompanying low-code app builder. So I will just go through briefly now the concepts, like why we built it, and then we can go into actually demoing it. Eric and Ramsey will help me with showing you guys how we did it in the workbench itself, in the ecosystem workbench, and also how we did it on our app environment. And then we can open it up to discussion. Now, just to give a bit of background, the concept here, the way that we wanted to demonstrate our philosophy really was that we wanted to create an app, some kind of an interactive space or situation scenario in which you could visually show and also physically show how a recommender could consider how a human would behave. So in this case, it was to take emotions and visual media as the trigger of such in order to identify a possible want after the fact. So we really wanted to keep this simple. So the app that we built is very uncomplicated. It's a relatively idealized view just to show very clearly how we demonstrate this concept of the relationship between emotion and recommendation. And then it's also designed as a deliberate illustration. So the problems that we wanted to solve and how we wanted to solve it was that we wanted to keep it low code. So as low code as possible, which in this case, we did manage to keep it entirely so. It must be human-centric in order to illustrate the human behaviors, to find a better way to have us show how behaviors can influence recommendation. All right, so another problem to solve, or another thing that we really wanted this to be, was a real-time application in order to be able to identify, view, and pick up on the patterns and how these convergences are happening, or how people are responding to the recommendations that are happening. Now, wanted to sort of look at these usual problems that are associated with humans, which are that they are constantly changing. Our preferences evolve continually. Our likes and dislikes change constantly. We are influenced by trends, external sources, influences, a number of different things. And we're also oftentimes a little confused about this obscure construct of emotion. So it's sometimes difficult to explain an emotion. So in this case, again, keeping to the concept being very simplified, is to use then an image that could evoke some kind of emotion. Now, whether this is a positive emotion or a negative emotion, we will always have a response to an image. Now, from that step where we then have an image that's presented that evokes that emotion, we then offer you an opportunity to assign, in relatively simple terms, an emotion to that image. So you choose an image of something, it made you feel isolated, and one of the options of an emotion is sadness, so then you would just associate that. And now the last step would then be to recommend something based on the combinations of the images that you chose and the emotion that you related to that image. All right, on this next slide, I've just got screenshots of our workbench and also of the app itself. So the way that we did this, our solution for it, was to, step one, build a dynamic recommender in the workbench. Now, I say one recommender. We ended up building, in fact, 3 recommenders because it was the best way to illustrate how this would all be put together. So the first recommender is your first step, which recommends the images. So you get 4 images. The second recommender is the recommendations of the emotions related to that image. And the third recommender will then recommend you, in this case, a movie based on the image and the emotion as I described now. Now, I just wanted to ask, before we get, is everyone with me? I'm speeding through this a little. Is everyone following so far?
What is the domain, to recommend the movie or to recommend the house?
To recommend a movie.
Okay, so you're using the house and the emotion in 2 steps as a way of testing what movies could be suggested.
Yes, absolutely.
Yeah, so they are used as essentially a contextual setup to be able to say what you do in the next phase. Because what we found, what works well, and you often hear that people say that, yes, we have implemented a model to do something. In our world, because we've got a technology that in real time can give you a response in single-digit milliseconds, means that you can create a multitude of contextual models. And each one of those can have its own training criteria and its own data collection. And you can even set up models that are adversarial, that could compete with each other, that's maybe trained on historical data and some that are not, at every context. And the idea is that if you then track that human's engagement over time, you don't just have a singular dimension, you've got a multidimensional view of their engagement with you. So Simon, that's kind of a... Jay, should I talk to this quickly then?
I think so, Jay.
Reinterpreting it through one of my own lenses, and that's if I get people to start rating tweets in my situation, I could try to deduce that engagement algorithm by saying, because you've rated this tweet in this way, I would be next sending you a tweet that is close or far away from that one. And then this process of continuous refinement is pretty similar to the engagement model, although I don't know what the Twitter engagement model is. But I'll be able to deduce by going through that kind of exercise.
Yeah, what you could even do, if you had a pipeline setup that's an automated pipeline, and let's say that you want to ingest your tweets either in real time or you want to do it delayed 5 minutes, 10 minutes, or an hour, or whatever. It means that you can generate your option stores, and the option store is essentially as the heart of where all of the engagements get tracked across the different online models. It basically means that you could ingest that continuously throughout a day and night. Your ingestion pipeline can happen, and it can regenerate your option store or update your option store dynamically throughout a day. And then your recommended behavior can shift and alter as new options are being presented to the person who's going to be presented with something that they can select. If you want to build something that is... Sorry?
No, I'm just saying that's prompted a whole chain of thought. I'm making notes here feverishly.
Yeah, so we're going to see 3 tracks. Is that there's a base track that deals with historical data or no historical data. So you can start this with a cold start if you want. And that means you can continuously ingest. You go second track, and that's the online engine. It's the way in which you'll be able to update your option stores and everything through ongoing engagement. And there's a third layer, and those are the parameters that you can tweak dynamically while you're in production to deal with how you want to include historical or time window. And Eric can talk to that in a moment. But there are a number of ways in which you can then set that. But architecturally, maybe just to quickly look at this picture is maybe a bit technical for some, but let's just think about it for a moment. You've got your operational environment, means that you have scoring engines and the total implementation permanently in production. So that means that you put it into production and it stays in production permanently. You don't have deployment pipelines that slow you down. You then have the business interface where you then going to call the pulse responder, or what we call the client pulse responder, through an API. And the backend parameters that update the scoring engine at the backend are evolving completely independently from how it gets used on the UI. So in the example later, you're going to see that Ramsey will show you how they did it in Adalo, that is a public platform, how they configure it to call the API. So that means the people that create the user interface that deals with presenting somebody with an offer and then getting a response back as people accept those is an entirely independent process from what happens in the back end when you configure it, and how you then track the performance in the back end. So the back end performance is your logging dashboard is used to track how often you engage in what your performance looks like, especially if you sit with tens of millions or hundreds of millions of people active accessing it. And in the front end is your scoring dashboards to deal with how the models are actually performing in production, because you could have, like I said earlier, multiple contexts that are set, and you want to track the performance of each one individually and then tweak your parameters to see how the behavior changes while you're in production. So the idea is you don't have the historical process where you go through an entire batch model training process and then put it into production. You are permanently in production, and you tweak the parameters to alter the behavior of the engagements while you are busy running live tests, especially if you're busy running live experiments. Anyway, the idea was just to show this as a context that it's an integrated architecture that bring all those components. I think that's it, Jess.
So, sure, thank you. So we will also be...
Stand up. Got a question, DLJ?
Oh, yeah, DLJ?
Oh, yeah, just a quick one, because my eyesight's not so good. There's a box that I can't read. Does it say real-time interventions across or access to of touch points?
Across all touch points.
Oh, across all touch points.
So what you could do when you configure your real-time intervention, you can set it up that in the API there's a channel, so you can decide that it comes through an app, a web interface, or various types of web interfaces, a USSD, a text message, call that maybe sit in a call center. So you bolt it into all of your channels. So you are completely channel agnostic. So we don't really deal with, I know that people use language like omni-channel. That's not how we think about it at all. We think of the fact that there's a single human engaging with your business, and you want to track across all the possible places where they're going to touch you. You want to be able to make sure that you track interventions and provide recommendations. Even if that recommendation goes to a representative of the company, like a call center agent, that will talk to the client or go directly to the client. You want to be able to have that interfacing so that you can collect behavioral data across all channels. Interaction.
Just as a quick follow-up then, what's the difference between interaction versus an intervention?
So an interaction is when I just interact with you. So that means that I get you to participate in responding to something. If it's an intervention, it means I assign something specifically to get you to act on a particular, like purchasing a product. I'll use an interaction to create an intervention.
Got it. Okay, thanks. That makes sense.
So the intervention is far more, I have now done something with you to get you to act based on the way I want you to act. Now that you are acting, I've given you a number of interactions. Those interactions now show positive outcomes by you acting on the intervention.
Yeah, thank you.